Hello students, welcome back to my channel. Today we'll be discussing questions which were asked on the 1st of February 2023 JEE mains. Okay. So in this video probably we'll be discussing questions based on units, dimensions and kinematics. So without wasting time, let us discuss them one by one. So here comes the first question. You can see students, this is van der Waals equation. Okay. It represents the equation of state of some gases where P is pressure, V is volume, etc. A, B, R are constants. The physical quantity which has dimension formula as that of. So this we have to find out the dimension formula for this, and then we have to check amongst the four options. Now this question is based on principle of homogeneity in dimensions, which states that two or more quantities can be added or subtracted if and only if they have the same dimension formula. Okay, this is plus. Okay, students. So here, in order to know the dimension formula of A and B, we will be using this concept of principle of homogeneity in dimensions. As you can see, pressure is being added to A by V square. So we can write the dimension formula of pressure is equivalent to that of A by V square. Therefore, dimension formula of A should be equivalent to pressure into volume square. Okay. Then similarly, you can see from volume B is deducted. So, volume should be dimensionally equivalent to that of B. Therefore, I can write that the dimension formula of B must be equivalent to that of B. So, let us find out what we have to do. We have to find out B square by A. So, B square means volume square from here, and A is P by V square. So, that is 1 by P. Okay. Now, you know, compressibility is the reciprocal of Bulk's modulus, and Bulk's modulus is equivalent to that of pressure change. Dimensionally, Bulk's modulus is equivalent to pressure, and compressibility is the reciprocal of pressure. So that is how A is the correct option. Moving to the next question. An object moves with speed v1, v2, v3 along a line segment AB, BC and CD. You can see this is the object, the diagram, where AB is equal to BC is equal to CD. Then average speed of the object. As you can see, they have given that for this part of the motion, AB speed is V1, then V2, then V3. Okay. Now students, I have already specified this earlier also in one of the videos, that in case if a particle travels with different speeds for equal distances, then the average speed can be calculated as number of segments. You can see how many segments are there. 3 different segments are there. So number of segments upon average speed is equal to 1 upon the speed corresponding to the first part of the motion, then 1 by V2, then 1 by V3. This is how you are supposed to find out. In fact, mathematically speaking, the average speed is nothing but the harmonic mean of V1, V2, V3, etc. Harmonic mean. Remember, this formula should be used only if the particle travels with different speeds for different equal distances. Only then you are supposed to use this. Okay. Upon simplification, you will have V2, V3 plus dot 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 upon V1, V2, V3. This 3 will get multiplied here. So C option is the correct option. Moving to the next question. If the speed of light, universal gas constant G and universal gravitational constant G and Planck's constant H are chosen as fundamental quantities, then dimensions of mass in the new system. Now student, the usual method which is taught in books and our teachers teach is this. That is, you are supposed to take, let us say, the power of H as X, power of C as Y, and power of G as Z, and this should be equated to M. Okay, then you write down the dimensional formula of H, C, and G, then collect the powers of M together, powers of L together, and powers of T together, and then you equate the powers of M and T on both sides. So this could be slightly lengthy. Okay. So in this particular case, we have a small trick. I am not telling that this trick can be applied universally in all the questions. But certainly in these kind of questions, it can be used. Where we can see we usually come across HC. Formula for energy is Hc by lambda, energy of an electromagnetic wave. So basically Hc can be written as E into lambda. So energy means m L square T power minus 2, and this lambda is again L, so total L cube we have. So this is the dimensional formula for Hc. And for gravitational constant G, from Newton's universal law of gravitation, we have this. Okay. So for force it is m L T power minus 2, then R square is again L, so L cube, and divided by L square is m power minus 1. Okay. Now in order to have the dimensions m, certainly you cannot multiply them. If you multiply them, then m and m power minus 1 will get cancelled. Certainly you have to divide this by this and extract the square root. Only then you will get m. Because when you divide equation 1 by 2, you will get m square, and when you extract the square root, you will get m. So basically, Hc upon G is m square. Can you see? Because L cube will get cancelled and T power minus 2 will also get cancelled. So therefore, m is dimensionally equivalent to h power half c to the power half upon g to the power half. So correct option is A option, you can see. Moving to the next question. A child stands on the edge of a cliff 10 meters above the ground and throws a stone horizontally with an initial speed of 5 meters per second. Neglecting the air resistance, the speed with which the stone hits the ground. What you can do is that you can straight away apply the law of conservation of mechanical energy in these cases. Suppose h is the height from which the ball has been thrown. Okay. Suppose initially it is thrown with the speed u, and if it strikes the earth's surface with the speed v, if you apply law of conservation of mechanical energy, where we can write as it comes down, there will be loss in gravitational potential energy, which will result in a gain in kinetic energy. So gain in kinetic energy will be equal to loss in gravitational potential energy. So gain in kinetic energy is half m v square minus u square. Loss in gravitational potential energy is mg into height lost. So when you cancel this, and finally you will get v square is equal to u square plus 2gh. One thing you have to notice, students, that this formula, it is independent of the direction of projection. Okay. The ball can be projected in any direction, regardless of the direction. This formula is always applicable. So let us substitute the values here. Substituting the values, u is given as 10. U is given as 5 meters per second. So 5 square plus 2 into g is 10, h is 10. So 10 into 10. So this will be 25 plus 200, that is 225. So v square is 225. So v will be square root of 225, that is 15 meters per second. A option is the correct option. Moving to the next question. For a train engine moving with speed this much, 20 meters per second, the driver must apply brakes at a distance of 500 meters away from the station for the train to come to rest at the station. If the brakes were applied at half of this distance, the train engine would cross the station with a speed root x meters per second. The value of x is. Now suppose this is the station. Okay. And let us say P is the point from where brakes have to be applied. This is a certain distance, fixed distance. Let us take it as D, which is given as 500 meters. Okay. We don't require actually 500 meters, but anyway, it's okay. Now the initial speed is u. So it is given that when it comes to the station, it perfectly stops. It comes to rest here. Okay. So final velocity is 0. It is clearly given that assume retardation to be constant, same retardation. So let us say the retardation is r. r for retardation and which is constant. So we can use equations of motion. Okay. So the equation which involves initial velocity, final velocity, displacement and acceleration is v square equal to u square plus 2as. Is it? So we have 0 is equal to u square minus 2r into d. So we have 2rd is equal to u square. Let us keep this as the equation 1. The next situation, it is given that brakes are applied at half the distance. Okay, so retardation is same, so acceleration is still minus r here. This is the train. I'll write T for train. Okay, so its initial speed is assumed to be same. So certainly, due to inadequate distance, it will have certain velocity. That's what we have to find. By the time it comes to the station, I'll write station as S. It will have certain speed. So again, rewriting the same, we will be using the same equation here. V square equal to u square plus 2s. We have v square is equal to u square minus 2r into d by 2. Now here you can see 2rd is u square. So I'll substitute here. So we have u square minus u square by 2, which is equal to u square by 2. Therefore, v is u by root 2. Okay. It will have a speed equal to u by root 2. So here, u is given as, you can see u is 20 meters per second. So 20 upon root 2. Since we have to write it as a square root of something, this can be written as under root 400 by 2. That is root over 200. So 200 is the correct answer. Then moving to the next question. That's all students in this video. Thank you so much for watching my channel.